Okay, so what we are taking a look at for this unit is describing relationships. We are going to be looking at bivariate numeric data. So this whole unit, bivariate, that means two variables, and then numeric, they're both numeric. So we're going to be looking at the relationship between two numeric variables. You display that in a scatter plot. And so that's what we're going to be talking about first is scatter plots. What information do they give us? And how do we measure the relationship, which we do in something called correlation. This is also a pretty calculator-heavy unit. So if you could this page, please. This is where we're going to start. We're going to start with an activity that I'm going to explain in a minute. Okay, so moving on. Why do we study two relationships, or why do we study the relationship between two variables, like in our case, hand size and number of candies, is to make predictions. Will wanted to be able to take somebody's hand size and use it to make a better prediction for how many candies that person can grab. It also helps us to explain phenomena. Again, this is for numeric data only. So we are not making any predictions for categorical data. That's possible, but it's not what we're doing. Okay, two pieces of vocab that you need to know, and you've heard these before, explanatory and response variables. Explanatory variable is the independent variable. Response is the dependent. So in our case, the explanatory or the independent variable would have been hand size. It's what's affecting the response. It's what's affecting the number of candies that someone can grab. The difference, how do you know what to put on each axis? The x-axis should be the explanatory or the independent variable. Are you guys okay if given two variables deciding which one would be the explanatory? You've done that in science a lot, probably. Okay, where do you start the axis? You do not need to start at 0, 0. So remember talking about for a histogram, you had to start the y-axis rather, you had to start frequency and relative frequency at 0, because if you started at a different value, it skewed the differences between the categories. That's not the case here. Starting your scatter plot, you can start wherever you want, because all you're doing is just looking at different parts of the scatter plot. So not starting at 0 isn't magnifying or changing any differences. When you are making a scatter plot, the easiest way to lose points is forgetting labels. We need to label the x-axis, the y-axis, and put a title. Okay, none of that is new. This is really the only thing that is probably new to you. When you are describing a scatter plot, there are 4 things you need to talk about. We've talked about so far that when we're describing numeric data, like a dot plot or a stem plot, we do CSSU. That is for univariate numeric data. So that is one variable only. If you have one numeric variable, you're going to use CSSU. So that is a ton of different graphs. Like I said, dot plot, histogram, stem and leaf plot. Those are all CSSU. For a scatter plot, which has two variables, the acronym you're going to use is FUDS. The only time you use FUDS is for a scatter plot. The F stands for form. There's really two forms. Either the graph looks linear or it's not linear. For nonlinear, you can say curved if that's appropriate. Don't let 1 or 2 points sway you. So same thing when we did shape before. We didn't allow shape to be determined by 1 or 2 points. U stands for anything unusual. That would be if you see outliers. There is no rule or calculation for outliers in a scatter plot like there would be on a dot plot. There could be clusters. That would be unusual. Okay. Direction. Direction can be positive, negative, or there can be none. The direction just follows the slope. So if slope is positive, it's positive direction. This is a general idea. Not all points will follow. So just because you have a positive slope doesn't mean that all of the points have a positive slope. And then lastly is strength. That just means how closely do we fall to a straight line. The strength can be weak, moderate, or strong. Okay, 2 things. You have to make sure you have context with both variable names. And then I wanted to show you something interesting. If we were to look at this, just those points right there, we would say that those points have a positive direction. They go up. These points also have a positive direction. But if you were looking to fit one line of best fit to this, the line of best fit likely would be here. So this is something unusual because we would say this cluster has a positive direction, this cluster has a positive direction, but overall they create a negative direction. So that is an example of something unusual that you could see. We are going to do this one example, and that is it. This will be the last of our notes today. Questions on the FUDS part? Okay, the scatter plot shows the amount in sodium and the amount of fat in salads from McDonald's, salads that have no dressing. Describe the relationship between sodium and fat. So when it says describe the relationship, you are thinking to yourself, there are 2 variables. So I'm going to use FUDS. The relationship between sodium and fat in salads from McDonald's That's the context. If we look at the scatter plot, it looks fairly linear, right? I could fit a line to it. It's positive. The points are generally going up. So the relationship is positive. In terms of strength, it's not strong, right? These points don't fall exactly on a line. So I would call it moderate. So it's positive, moderate, and linear. So I've done everything except the unusual part. For unusual, it looks like there's 3 clusters. So there are 3 clusters. And then we're going to say where those are. With sodium values, so I'm looking at the x-axis, centered around 200, 600, and 900 milligrams. Just using your own thinking brain now, not being robots anymore, any idea why there might have been those 3?
Different locations or something.
So they're all salads. They don't have dressing, so it can't be dressing. What else could cause there to be a difference in the sodium and fat with a salad?
Different types of salads?
What do you mean?
Like different stuff in the salad?
What do you think specifically is the different stuff in the salads? Proteins. Okay, great, love that idea. This has no protein. This one has chicken. This one also has chicken. What could be the difference between those 2 chickens? Grilled and fried. Yep. This one is grilled chicken. This one is fried chicken. Last thing I want to tell you is, in this case, there is no explanatory variable. Either one could have been on the x-axis. We could have had sodium or fat, either one. Questions for me? Will?